Pip.Services Toolkit, one of a very few technologies that allows to build microservices in different languages and then deploy them on a variety of platforms. When we architected it, we followed a few core principles. First of all, it was designed from ground up to be implemented in different languages. We intentionally stay away from features and mechanisms that are unique to a specific language. For instance, dependency injection is a popular pattern for inversion of control, but we chose to go with locator pattern that doesn't require reflection and can be implemented in any languages, including compiled ones. It also has symmetric implementation, which means that in every language you'll see the same set of classes, methods, and parameters for those methods. That allows developers who learned implementation in one language easily switch to another language and reuse their skills. When they build microservices, they interoperable out of the box. They have not only method invocations or messaging from one language directly transferable to another one, but it also helps with things like error propagation. The framework prefers composition over inheritance, and that allows to work with existing code bases when you can take existing class and implement a few core interfaces, extend functionality of that component, and integrate with other toolkit components. The toolkit is broken into a few small modules that helps to keep the footprint as little as possible and bring only required dependencies into the implementation. And it was very important to support deployment across different platforms. In many situations, that can be done only by flexible deployment configurations, which enable and disable specific components based on the platform where it's deployed on. The architecture consists of a core that has 7 modules. 3 of them, like commands, components, and extensions, will be included in every implementation, and container, data, RPC, and messaging all will only be included if application or microservice uses specific patterns. And then there is a variety of technology-specific modules that integrate popular technologies into components that can be reused in the toolkit. Commands modules provide cross-language primitives like abstractions over reflection or data converters, and common implementation patterns such as configurations, dependency injection, data validation, data processing patterns, and so on. Expressions module has tokenizers and patterns to perform syntactic and lexical analysis. Now it's primarily used for Mustache template engine that is used to change configurations based on the deployment scenarios. Components modules has definition for standard components such as configurators, connection parameters and credentials, distributed logs, distributed caches, loggers, tracers, performance counters, and more. Then those component definitions used in technology-specific modules to implement components for specific technology. Container module provides inversion of control container that can assemble microservices from loosely coupled components following the deployment configuration. Data modules bring a few data processing patterns and abstract implementation for persistence components. RPC module implements patterns for synchronous method invocations. It has implementation for RESTful services and for direct invocation for in-process communication. Messaging modules provides patterns for asynchronous messaging, and it also has patterns to implement event-driven systems. And there is a large variety of technology-specific modules that take particular technology and wrap it into components that can be deployed alongside with other toolkit components. All the toolkit source code is located on GitHub, where each language and major version is stored in a separate repository. All the source code is released under MIT license, which is free for commercial and non-commercial use. If you're interested to learn more about Pip.Services Toolkit, please visit our website at www.pipservices.org and subscribe to our channel. Thank you.